Hi friends! So today I'd like to talk about classification. Basically, classification is to assign the individual observation in the population to the class it belongs to. And usually classes are independent of each other. For instance, whether a person will like the video or not, whether a person will like country music, rock and roll, or piano. And in this case, we will use the IRIS dataset, IRIS. To better understand this dataset, we can use view iris, and it has 5 variables, 4 are numerical, and 1 are categorical. As we can see, there are in total 3 species of iris, and in total 150 observations. So because of this, we can use k-means clustering. So basically, k-means clustering will separate this 150 observations into 3 clusters, in which each observation belongs to the cluster with the nearest mean. This is a built-in function of R, and it's relatively simple to understand. To do so, we first want to remove the species column of our original data, so we can assign a new name to the IRIS dataset called IRIS features. And then we can assign the species column in IRIS features to null, so as we get rid of the species dataset as shown here. And then we can call k-means on our new dataset with the predefined cluster 3, because there are 3 species of iris in total, iris. And then we can show the results. So the results indicated that there are 38 observations in cluster 1, 50 in cluster 2, and 62 in cluster 3. And calling results cluster, we will see the individual observations cluster number. So how good is k-means clustering? We need to check it with our original dataset. To do that, we can create a new table with the iris species column and results cluster column. And as shown here, we can see that it did a relatively good job with Setosa all accurate in cluster 2, and versicolor moderately accurate with 2 errors. And then Virginica, there are some errors because 14 are assigned in cluster 3. And then we want to visualize whether these 2 differences. We can do that first on the petal data. So we have petal length and petal width as our numerical variables, and we can call on the results data and the iris data. And as shown here, the first one is the k-means results, and the second one is the iris actual data. And as we can see, it's relatively similar. The 3 clusters are pretty clear. Then what about the sepal data? We can do the similar things by replacing sepal with petal with sepal, and we'll assign color to the same column. And by doing so, we get another 2 graphs. So this first graph indicates a cluster of sepal with using the results data, and the second graph is from the actual data. And as we can see, there are some differences in the middle of the section, with the actual data have more intertwined, and the k-means clustering are more separate from each other. But besides that, I think k-means clustering is a good classification for IRIS dataset. And so this concludes the example. And for more information, I recommend visiting these two websites. Thank you.